Today we will review 6th grade math lesson 5.3. This lesson will cover comparing ratios and rates. Here's your I can statement. I can compare ratios and rates using a table or a double number line and explain my solution methods to others. Unit rates can be used to compare ratios and rates. Ratios or rates can also be compared by setting equivalent values for one of the units in the ratio. Let's look at the first example here. Kyle and Megan are taking a typing test. The table shows the number of words they type over time. Who types at a faster rate? So we're trying to figure out who types at a faster rate by comparing Megan's and Kyle's. So here's this Kyle's here, and here's Megan's. Find ratios where one of the quantities from Megan's table and from Kyle's table is the same. So that's our first step here, is we want to look at the tables below and see if we can find quantities that are the same. So if you notice here, they both have 60 seconds as a same quantity. So we're looking here. And so 60 seconds is the same quantity for both. So then we look at the table here, and if Kyle types 40 words in 60 seconds. So here Kyle's typing 40 words in 60 seconds. And then Megan's typing 45 words in 60 seconds. I'm going to change the color on this one so we can just do, let's see, Kyle's going to be this. So Kyle types 40 words in 60 seconds, and Megan types 45 words in 60 seconds. Step 2, compare the ratios by comparing the different quantities. So we write them here as a ratio, and we're saying that this is Kyle's. He is 40 words per second, and then here is Megan. She is 45 words per 60 seconds. So when we compare them, we can use the inequality, and we can say that 40 words per 60 seconds is less than 40 words for 60 seconds. Then the last step is we want to state our solution. So we want to go back here and make sure, what is the question asking me? They're asking who types at a faster rate. Megan types at a faster rate because Kyle's rate of 40 words is less than. So Megan types at a faster rate. Let's look at the next one. A telecommunications company, it's like a phone company, offers 2 calling cards. The first card costs $25 for 750 minutes, while the second card costs $40 for 1,300 minutes. Which is the better buy? So let's see. The first card cost $25 for 75 minutes, and the second card costs $40 for 1,300 minutes. So we can go ahead and make a table. We're trying to find a quantity that has the same for both. That's step 1. So a good strategy is to find the unit rate. So if I do a table here, and then cost and minute, this is going to be for the second one, and this will be for the first one. So this is plan 1, and this is plan number 2. Okay, so they gave me the first card cost $25 for 750 minutes, and the second one is $40 for 1,300 minutes. Now, if I want the cost to be $1, I could do 750 over 25, and if I divide these both by 25, because what I do to the numerator must do to the denominator, and I want to get this as 1 because that's my cost in dollars, okay? So 750 divided by 25 is 30. So I know that would be 30 minutes for $1. So that is plan number 1. And if I do plan number 2 here, I know I'm going to do that up here. I have $40 for 1,300 minutes. Oops, I have that reversed. Sorry, let me do it again. If I divide both of them by 40, then I'm going to get $1 here. So 1,300 divided by 40 is 32.5, and that's my minutes. So for $1, I get 32.5 minutes with plan 2. So the question that they're asking me is which one is a better buy? Which one is I'm going to spend less money and I get more minutes? So card number 2 is the better buy because I can talk 32.5 minutes for $1. Let's look at number 2. The rate at which Pete's Bakery can make pies is shown on the graph below. So we know this is Pete's Bakery here because it's shown in the graph below. And we know that we're comparing two things. We're comparing hours and pies. How many pies can they make per hour? So sometimes when I have a graph here, I can look at the table. And I see here they have the number 2 and 6. So they're telling me that 2 hours they can make 6 pies. And then I look at this one here, this next point on the graph, and that's 3 pies for 9 hours. And then 4 pies for 12 hours and 5 pies for 15. What would be the unit rate? I know that the unit rate here, if I have 2 pies for 6 hours, I'm sorry, I need to do that. I keep doing that backwards. Let's try again. If I have 6 pies in 2 hours, how many could I do in 1 hour? So 2 divided by 2 would equal 1 hour. And then 6 divided by 2 is 3. So I know I can make 3 pies in 1 hour. That is my unit rate. So if I take my unit rate of 3 pies in 1 hour, this question says, how many pies can Pete make in 7 hours? So I use my knowledge of equivalent fractions here. 1 times 7 is 7. So in 7 hours, I can make 3 times 7 is 21 pies. So the answer is 21 pies. Question B, Kamala's Bakery, okay, so this is a new bakery here, it's not Pete's, can make 5 pies in 2.5 hours. So if you have Kamala's, she does 5 pies in 2.5 hours. Let's find out her unit rate. So to get her unit rate out of 1 hour, I would need to divide and make an equivalent ratio here. So I need to divide this by 2.5. What I do to the denominator, I must do to the numerator. So 2.5 divided by 2.5 is 1 hour. 5 pies divided by 2.5 is 2. So I know the unit rate for Kamala's is 2 pies for every hour. And then what is Pete's unit rate? So we know Pete's is right here, and here's Pete's unit rate. It is 3 pies for every hour. And then we have Kamala's, and Kamala's is 2 pies. So who makes more pies? Who has the faster rate? So I know that Pete makes pies faster because he makes 3 pies per hour. That is our lesson for Module 5, Lesson 3 for Grade 6.